Welcome to the student of class 12. Today is the first online class. So we choose a easy topic that is well known to all of you. Which topic today? Today we study about vectors, which is well known to all of you in class 11 in physics. Not only that, on class 11 you know what is vector and scalar from class 9 also. Okay, if we divide physical quantity in two parts, we know that one is scalar, another is vector. Scalar, which has only magnitude, and vectors, magnitude and definite direction. Magnitude and definite direction in space. If the question is define a vector, most of the students say the quantity which is magnitude and direction, but I think it is not totally correct, it is partially correct. I give you two examples which has both magnitude and direction, but it is not a vector quantity. For one, in your physics, current, it is also magnitude and direction, but it is not a vector quantity. It is known to all of you most probably. And in maths, there another example which has both magnitude and direction, but it is not a vector quantity, that is an angle. In trigonometrical angle, we know that angle is the amount of turning either clockwise or anti-clockwise. So this is the magnitude and as well as direction also, but it is not a vector quantity. So what is vector? You must mention that it follows triangle law of addition. Vector, magnitude and direction, and it follows triangle law of addition. Okay. So to define a vector, you must mention it. It follows triangle law of addition. It is known to all of you. There are so many types of vectors. Like what is triangle of addition, discuss later on. So many types of vectors: null vector, unit vector, equal vector, negative vector, like and unlike vectors, collinear vectors, co-initial vector. It is now all known to all of you. Co-initial means starting position same. Null vector means magnitude is 0. Unit vector, magnitude is 1, etc. It is known to all of you. Coplanar vectors, that means lie in the same plane. Free vector and position vector. Position vector discuss we after that. Position vector we define here. Now what is triangle law of addition? First we discuss about triangle law of addition. It is also known to you. Suppose OA is a vector and AB is another vector. Then the magnitude and direction of these two vectors OA and AB is nothing but OB. That means OA vector plus AB vector is equal to OB vector. OA vector plus AB vector is equal to OB vector. To define a vector, you must write the arrow. So OA plus AB is equal to OB. If OA vector is denoted by small a vector and AB vector denoted by small b vector, then OB vector is nothing but A vector plus B vector. And magnitude of a vector is, this is the magnitude of A. Magnitude of A is denoted by this. Magnitude of vector A is denoted by this. It is known to you. You must mention arrow, and this is the mod sign. Magnitude of vector A is defined in this way. Okay. Next, position vector. Position vector, if we define a position vector, so we take a origin with respect to some point, then we define position vector with respect to some point. Here the position vector of A is small a and position vector of B is small b with respect to some origin O. With respect to O. So if we define position vector, we take a origin must. So position vector of A is small a vector. Here we write PV, that means position vector. That is, OA vector is nothing but a vector. OA vector is nothing but a vector. Similarly, position vector of B is small v, that is, we can conclude OB vector with respect to O, obviously. OB vector is V vector. Now, if we find the vector AB, and I think triangle law is very important in vector algebra. Triangle law of addition is very important. I repeat once again. If we know the triangle law, then we can easy to prove everything on vector. Now, OA vector plus AB vector is equal to OB vector. OA vector plus AB vector. OA plus AB is nothing but OB by triangle law of addition of vectors. Now, OA vector is nothing but position vector is given. OA vector is A, so it is A. AB vector remain intact, and OB vector is B with the definition. Now, if we take into left hand side, then AB vector is nothing but B minus A. So, if position vector of 2 points are given, if we find that vectors, this is nothing but position vector of B, AB vector, that is equals to position vector of B minus position vector of A. So, B, if it is N, first B, then A. Okay. Position vector of A, sorry, it is position vector of A, this one, point A. So, position vector AB is equal to position vector of B minus position vector of A. This is the concept of position vector. Next, parallelogram law of vectors. This is again with the help of triangle law. Now, if the initial position of two vectors are same, that means co-initial vector same, there are two vectors, one is AB vector and another is AC vector. AB and AC are two vectors. Next, we have to find out the resultant of these two vectors. This is nothing but, if we complete a parallelogram with two adjacent sides are AB and AC, two adjacent sides are AB and AC, that means the parallelogram ABDC. ABDC, complete the parallelogram ABDC. Clear? Now, obviously, if it is a parallelogram, opposite sides are equal and opposite sides are parallel also. So, AC vector and BD vectors are same, since AC is parallel to BD and AC equals to BD, length are same. So, AC vector and BD vector are same. Now, from the triangle law, AB plus BD is nothing but AD. AB plus BD is nothing but AD vectors. That means instead of BD we can write AC also. So AB plus AC is nothing but AD. That means resultant of these two vectors is the diagonal AD. So A and B, AB and AC are two co-initial vectors. That means initial positions are same. Then their resultant is nothing but, if we complete a parallelogram whose two adjacent sides are A and B, diagonal of this parallelogram is the resultant of this. Okay. Next, division of a segment in given ratio, like coordinate geometry. If a straight line divides in m:n ratio, then we find the coordinate of the point which divides a line segment with m:n ratio. Here, position vector in vector method, position vector of A and position vector of B is given. Position vector of A is small a and position vector of B is small b with respect to some origin O, and P is a point on AB which divides AB in ratio m:n. That is, AP is to PB, AP is to PB is m:n. Then we can find position vector of P, position vector of P is say R is equal to MB plus NA by M plus N, like coordinate. M into the position vector of B plus N into position vector of A. M into position vector of B plus N into position vector of A, just in reverse, divided by M plus N. very easy to prove. It is very easy. So if we prove this, how? If we find AP vector by triangle law, again I repeat, triangle law is very important here. AP vector is equal to nothing but AP vector is equal to position vector of P minus position vector of A, like previous one, that means R minus A vector. And PB vector is nothing but position vector of B minus position vector of P. Position vector of B is small b with respect to origin O, and position vector of P is R. So AP is to PB is M is to N. Just put here, and after simplification we get the result very easily. Now if is the midpoint, if P is the midpoint, then what happens? Then the ratio will be M is to N will be how much? If it is midpoint, 1 is to 1. So if M is to N is 1 is to 1, then say position vector of midpoint is R1, say R1 is equal to M is equal to 1, N is equal to 1, that is B plus A by 1 plus 1, B plus A by 2, or A plus B by 2. So midpoint, position vector of midpoint of the line segment AB, position vector of A is given and position vector of B is given, A and B. We get, just adding these two and dividing by 2, we get the midpoint. Now the question is the external division. For external division, P is a point outside the AB. P is a point outside the AB, then what happens? Like that, position vector of A is A and position vector of B is B, and position vector of P say R. P lies outside the line segment AB, outside. In this case also AP is to PB is M is to N, the same things. Then we get in the exactly as before, in this way, R is equal to nothing but M into B plus N into A by M minus N. Just instead of plus, it is right here minus only. Instead of plus, the formula will be minus. Like that, coordinate geometry. If a line segment divides like x1 y1 and x2 y2, mx2 plus nx1 by m plus n, my2 plus ny, y1 by m plus n, like that. For external division, it is minus. It's clear? Very easy. Next, I write one question, and very well known question, midpoints theorem. So that the line joining the middle point of two sides of a triangle is parallel to the third side and is half of its length. Prove by it vector method. By vector method. You prove it in geometry in class 9, this theorem, and there required construction, etc. If we prove it in vector method, then very easy to prove it. I repeat once again, the midpoints joining these two point is parallel and half of the third side. So let us take a triangle ABC whose ABC be any triangle. D and E are the midpoint of AB and AC respectively. D is the midpoint of AB and E is the midpoint of AC. Now if we join D, then we have to prove D is parallel to BC, the third side, and D is also half of the length of this side, that means length of BC. D is half of BC. So ABC be any triangle, D and E are the midpoints of the side AB and AC respectively. Let A, small b, small c, small d and small e are the position vector of the point A, B, C, D and E respectively with respect to some origin which is not in your figure. No problem. If we draw a point O, say, then the position vector of A is small a, position vector of B is small b, small position vector of C is small c, etc., D, E, etc. Now, in this case, which is not in figure, I write here. So, D is the midpoint. By the previous article, we can conclude D is the midpoint. So, A and B position vector are given. So, small d is nothing but, small d is the position vector of D, small d is nothing but A plus B by 2. Similarly, E is the midpoint of A and C, and position vector of A is small a and position vector of C is small c. Therefore, position vector of E is small a plus small c by 2. A vector plus C vector by 2. Now D vector, if we find D vector, then we can write the position vector of E minus position vector of D with respect to the same origin. So position vector of E and position vector of D. Now position vector of E, capital E small e, and it is given by, and position vector of D is A plus, this is D, E minus D is D vector. So if we write this is A plus C by 2 instead of E, A plus C by 2, and instead of D we can write A plus B by 2, A plus B by 2. After simplification, very easy simplification, A cancel out, then we get C minus B by 2. C minus B is nothing but this vector B to C. Position vector of C minus position vector of B is this vector. So, and half is common, so half of B into C. So DE is, we have already proved, DE vector is equal to half of BC vector. So this must be parallel. So DE and BC are parallel to each other, and the constant is given half. So modulus of DE is half of modulus of B and C. Modulus of B and C. So D is equal to half of BC. This proves the theorem very easily. Position vector of a point in coordinate plane. First we study about in 2 dimension, next 3 dimension. First in 2 dimension, next in 3 dimension. We know that along x-axis, unit vector along x-axis is defined I cap, along y-axis is j cap, and along z-axis is k cap. Unit vector, that means magnitude is 1. Now suppose P is a point in xy plane whose coordinate is x comma y. So what happens? If we draw a perpendicular from P along x-axis, that means OX, OM is the perpendicular, PM is perpendicular to OX and PN is perpendicular to OY. That means this is nothing but, if the coordinate is x comma y, that means OM is equal to x, and PM, that is ON is equal to PM, that is equals to y, since the coordinate is x comma y. It is known to all of us. Now along x-axis unit vector is I cap, that means suppose let OA is the unit length along x-axis OA. So OA vector is nothing but I cap, unit vector, and OB is unit length along y-axis, so OB is j cap. So if this length is OM is x, therefore OM vector is equal to how much? OM vector OM. If we define in vector notation, then OM vector is nothing but x times I cap. Since this length is a, magnitude is x, and unit vector along x-axis is I, so it will be x I cap. And ON vector is nothing but MP vector. ON is equal to MP, that is equals to how much? Unit vector along y-axis is j, so, and magnitude is y, PM, since PM is y and ON is also y, so MP vector or ON vector is yj cap. So this is x I cap and this vector is yj cap. Now again using triangle law, OP vector, we have to find out the position vector of P in terms of xi and yj. So OP vector is nothing but, OP vector is equal to OM vector by triangle law plus MP vector. Now OP, that is R vector, is equal to OM is nothing but xi cap, and MP is nothing but yj cap. So R vector is equal to xi cap plus yj cap. R vector is equal to xi cap plus yj cap in 2 dimension. It is right here also. So keep it in your mind, you get very easily. Now it is in 3 dimensional figure. Try to draw here. P is a point xyz, whose coordinate is xyz, three-dimensional figure. If we draw a perpendicular PQ on xy plane, so then along x-axis, this is x-axis, along x-axis unit vector is I, along y-axis unit vector is j, and along z-axis unit vector is k. Along z-axis unit vector is k. In the similar manner, if we draw a perpendicular, then we find, so this point is q point, the projection L on xy plane, q, this is xy0, xy0. That means OQ vector is equal to xi plus yj, and this vector is nothing but PQ. OQ, in this case, OQ vector is equal to xi cap plus yj cap by previous theorem, xi cap plus yj cap, and this vector QP or OT, these are same, not in figure. This is 3-dimension figure. Try to draw in 2 dimension. So QP, this is QP and OT are same. This is nothing but unit vector on z axis is k, and this length is z. This length is z. Therefore, this is OT vector is equal to QP, that is equals to zk cap. Therefore, from this triangle OQ plus QP is equal to OP. Then we can write OP vector R is equal to xi plus yj. OP vector can be written as, first we write OP vector is equal to OQ plus QP. Then OP vector is equal to that R, that is xi plus yj plus zk in 3 dimension also. From the 2 dimension we can conclude in 3 dimension also in the similar manner. So any position vector of any point in whose coordinate is given x, y, z is given by, very easily we can solve, is xi plus yj plus zk, xi plus yj plus zk. If the position vector of the points A, B and C are 3i minus 4j minus 4k, 2i minus j plus k and I minus 3j minus 5k respectively, then so that ABC is a right angle triangle. That means position vector of 3 points A, B and C are given in terms of I, j, k. We have to prove this forms right angle triangle. Right angle triangles, angle between two straight lines is 90 degree in next chapter, that means in vector product. If we solve this problem in this chapter also, no problem at all. Just we use the Pythagoras theorem, perpendicular square plus base square is equal to hypotenuse square. That means sum of the square of two sides is equal to the square of the third side. That means perpendicular square plus base square is equal to hypotenuse square. Okay. So here we write the position vector of A 3i minus 4j minus 4k, position vector of B is given 2i minus j plus k, and position vector of C is I minus 3j minus 5k. Now AB vector is nothing but position vector of B minus position vector of A, position vector of B minus position vector of A, and subtracting in this way I, j, k, k. So 2 minus 3, 2i minus 3, that is minus I minus j minus minus plus 4k, so it will be plus 3k, k minus minus plus 4k, that means 5k. So length of AB, that means magnitude of AB is nothing but, if position vector of any is given xi plus yj plus zk, then its magnitude, this is say R vector, then R modulus of R is nothing but x square plus y square plus z square, x square plus y square plus z square, xi plus yj plus zk, the magnitude of this is root over of x square plus y square plus z square is known to all of you. Now, so length of AB, that means magnitude of AB vector is root over of minus 1 square plus 3 square plus 5 square, that is nothing but 25 plus 9 plus 1, that is root 35. Here we write ABC. It is not required, obviously. It is, if we draw this or not, no matter at all. So similarly, position vector of this length of AB, similarly B and C, we find this B and C. So position vector of C minus position vector of B, in the same way, minus I minus 2j minus 6k, very easy. I, this is minus 2I, so it will be minus I, minus 3 plus 1, that is minus 2, minus 5 plus 1, sorry, this is minus 1, so it's minus 6. So the length of this side B and C is root over of this 1 square plus 2 square plus 6 square, that is nothing but root 41. In the same manner, C and A, C a vector, position vector of A minus position vector of C. Position vector of A first, I repeat once again, minus position vector of C, that is nothing but 2I minus j plus k. So length of CA, that means magnitude of CA, mod of CA, in the same manner, 2 square plus 1 square plus 1 square, sorry, this is minus 1 square, it will be plus 1 also, so it is root 6. So length of CA is root 6. So clearly we see that if we squaring this 35 plus 6, root 35 square means 35, root 6 square means 6. So AB square plus AC square is 35 plus 6, that is 41, that is BC square, it is root 41. So this is the perpendicular, this is the base, or vice versa, obviously is equal to this. So angle BAC is 90 degree. Therefore angle BAC is equal to 90 degree. Angle BAC is 90 degree. Therefore, if three position vector of 3 points are given A, B and C, therefore it forms a right angle triangle, obviously, since AB square plus AC square is equal to B and C square, length of this. So we prove this, it is a right angle triangle. Next question, if A is equal to I plus j plus k, B is equal to 2I minus j plus 3k, C is equal to I minus 2j plus k, find unit vector in the direction of parallel to a vector 2A minus B plus 3C. Find an unit vector, obviously. A unit vector, it is find an unit vector. There are two unit vector. Here we write only plus. So first find 2A minus B plus 3C. 2 into A is nothing but I plus j plus k. B is minus B. So 2 into A plus minus B. B means my 2I minus j plus 3k, and 3C. That means 3 into I minus 2j plus k. Now I is common, that means from here 2 minus 2, this is plus 3 into I. In the second, j, 2 into j, that means 2 minus minus plus 1, and this is minus 2j plus 3, minus 2 into 3, that is minus 6. So it is minus. Next k, 2 into k, that is 2, minus 3, minus 1 into 3, minus 3, and this is plus 3. So after simplification we get 3i minus 3j plus 2k. Very simple, 2 to cancel out, 3i, this is minus 3 and this is 2. Now this is the vector parallel to 2a minus 3b plus 3c in the same direction, since it is parallel or not, no problem at all. So unit vector of any vector, suppose there are a vector, suppose ABCD is a vector. So unit vector along this direction is given by this vector divided by modulus of this vector. Very simple. If we find the unit vector along any vector, any direction, vectors is given, then just find this vector divided by unit vector. Like that, if R is a vector, say xi plus yj, xi cap plus yj cap plus zj cap, zj cap, then unit vector along this direction is r by mod r. This is given by unit vector along this, unit vector along r. If we take plus minus, then either in both the direction, but in this question it is given find an unit vector, so we take positive sign only. No problem at all if we take negative. Plus minus is the better for unit vector. If this direction is in this direction is positive, then in this direction is negative, or in other way, if upward is positive vector, then downward must be negative vector. So is vector divided by modulus of this. Just calculating, we get this modulus 3 square plus 3 square plus 2 square, 994. 9 plus 9 plus 4, that is nothing but 22. 1 by root 22, 3i minus 3j plus 2k. It is better if the question find unit vector in the direction of parallel to a vector, then we just write here just plus minus 1 by root 22. If we take plus minus, then no problem at all. 3i cap minus 3j cap plus 2k cap, unit vector along both the direction. Okay.